Remember, no action on your part is in fact an action. Mother Nature dislikes a vacuum, and unless you do not care how that vacuum is filled, you will need to do something. Unless you lose your woodland to a catastrophic event, such as a wildfire or a tornado, the time to start thinking about the next generation is before the current generation is harvested. This type of cutting is called a regeneration cut. Regeneration cuts, or systems, have such a significant impact on the character of the new stand that they have unique names. They are clear cutting, seed tree, shelter wood, group selection, and single tree selection. Each system controls the amount of sunlight reaching the forest floor, and therefore influences the type of forest that develops. The system you select will depend upon your objectives, maintaining or introducing the species in your woodlands that meets those objectives, the ecological requirements of those species, whether you want an even or uneven aged forest, site condition, and economics. Clear cutting, seed tree, and shelter wood systems result in even-aged forests. Even-aged means that the dominant and codominant trees will be relatively the same age, usually within 3 to 5 years of each other. Group selection and single tree systems create an uneven-aged forest, where varying age trees make up the main forest canopy. Clear cutting is often confused with practices that convert land to some other use, such as a pasture or housing development. Clear cutting results in a new forest. It removes all the trees greater than 2 inches in one operation. Merchantable trees are harvested, and depending upon where you live, local sawmill capabilities, and current market needs, minimum tree size will vary. Unmerchantable trees are cut down or deadened on the stump, except for those trees left as wildlife den trees and trees along streams. The new stand develops from advanced regeneration, new seedlings, and stump sprouts. Advanced regeneration refers to those desirable tree species that are about head high and smaller. They probably resulted from a good seed crop that happened within the past 3 to 5 years and have been hanging on in the understory. Unless released in a timely manner, these individuals often die due to lack of sunlight and adequate growing space. New seedlings can be pretty small and are often overlooked by the casual observer. They are most often the result of a good seed crop within the past 1 to 2 years. Stump sprouts are usually the best and surest way to establish a new forest here in Missouri, particularly when it comes to oak trees. Most of our oak species are prolific sprouters. These sprouts have the established root system of their predecessors and can put on significant height growth that quickly reestablishes the forest. If the stumps are cut low enough, the resulting sprout has a good connection with the root system and will produce a straight stem. Clear cutting may be appropriate when the majority of trees in the forest are over mature or have been killed by fire, insects, disease, or wind. Another common situation is rehabilitating a high-graded forest. High grading is the practice of taking the best trees and leaving the worst trees to grow. The misconception here is that by removing the big trees, the little trees will have plenty of room to grow. The fact is that in most, if not all cases, those little trees are the suppressed trees and are every bit as old as the dominant and codominant trees. Even if given every chance, they will never realize their potential because they have been suppressed too long. The main risk with this system is the chance for erosion and sedimentation of small streams due to lack of forest cover. To minimize this risk, best management practices are usually followed that properly place skid trails, log landings, and haul roads, delineation of streamside management zones where harvesting is restricted, and reseeding of all disturbed areas with quick-growing forbs and grasses. As the name implies, the seed tree system leaves scattered trees throughout the area to provide seed for the next stand. Once the new seedlings are established, the seed trees may be harvested or left to grow until the next regeneration cut. This system, however, will only work for light-seeded species such as shortleaf pine. Seed trees should be healthy, large-crowned, with a strong root system to withstand the high winds that will now sweep across the harvested site. You should plan to leave about 10 to 15 well-distributed seed trees per acre. For proper regeneration, you will need to remove the litter on the forest floor. This exposes bare mineral soil to allow the seed to quickly take root upon germination. It will also kill unwanted understory species to allow the young seedlings to grow in the absence of oppressive competition. The risks involved with the system are: seed trees may be killed before they produce any seed. Harvesting seed trees could damage the young seedlings. There could be a long delay in seed crops, resulting in the subsequent invasion of competing vegetation. And there is little control over the density spacing of your new forest. You will get what Mother Nature gives you. The shelterwood system is similar to seed tree, but more trees are left and the new forest is established under partial shade of the older trees. The remaining trees, or overstory, are then removed to release the regenerated stand. 2 cuttings are commonly made, but occasionally 3 harvests are necessary. In the 3-cut system, the first harvest leaves the best trees with plenty of growing room to expand their crowns and produce seed. This cut can be eliminated if improvement cuts have been made throughout the life of the forest and have accomplished the same results. The second cut is made several years later when there is a good seed crop. Cutting and removing these trees bares mineral soil, preparing the site for seed germination. This cut also allows more sunlight to reach the forest floor, thereby stimulating the new seedling's growth. The final cut removes the remaining mature trees, releasing the young stand. The shelterwood system is used to establish advanced regeneration before a final harvest. It is most appropriate where the desired species to be regenerated can grow under partial shade. Seed trees are not subject to wind damage, and the increased cost of several partial cuts is acceptable to the landowner. As we can see in this brief clip, Scott was able to combine his improvement cut with a commercial sale. The result is a shelterwood with good advanced regeneration, well on its way to establishing the next forest. Also note that even in this stand, Scott is always seeking the opportunity for removing unwanted trees from his forest. The group selection system harvests small groups of trees. These openings resemble miniature clear cuts, but the resulting regeneration occupies too small an area to be considered an even-age stand. Improvement and harvest cuts are made at the same time. The new trees that come up in these small openings are regarded as parts of a larger forest that contains trees of many ages. Frequent harvests are the key in maintaining the proper balance of tree ages and sizes. Oaks and hickories can be regenerated using group selection. Oaks will grow best in the center of the opening where they receive more sunlight, and the hickories will do better in the shadier fringes of the opening. These openings vary in size from 1/10 to 1/2 acre based upon surrounding tree heights, slope, and aspect. Group selection maintains the aesthetic qualities of an unbroken forest. It is well suited to small woodlands where occasional cuts are desired, but where regular harvests are not important. The system produces excellent wildlife habitat, including openings with abundant forage and browse, a large amount of edge, and many mass-producing trees. However, group selection is more difficult for the landowner to apply compared to the other systems discussed thus far. Trees of all sizes should be in the stand at all times. When harvesting, trees of every size must be removed to maintain the uneven-aged forest. In addition, the small group openings must be located to take advantage of advanced regeneration, pockets of merchantable or dying trees, or to provide special wildlife benefits. It is usually a good idea to seek help from a professional forester if you want to implement this cutting system in your woodland. Like group selection, the single tree selection system creates and maintains an uneven-aged forest. Each tree is evaluated independently from the other trees in the stand. Individual trees are harvested as they reach maturity, and seedlings grow up in the resulting open spaces. Uneven age management allows for the retention of a forest on every acre, even immediately after a harvest. Because relatively few trees are harvested at any one time, and because the forest floor is generally shaded, this system favors species that are shade tolerant, such as red and sugar maple. It will not produce many oaks and hickories. Those few individuals that do arise will remain as suppressed trees. As a result, wildlife species that depend upon mass-producing oak and hickory trees will suffer. Forage and browse are scant under the nearly complete crown cover, and edge habitat that is important to many wildlife species is simply not present. The name of single tree selection is often invoked when an unscrupulous logger high-grades the forest. The primary difference between these two practices is that in single tree selection, the tree is only harvested when it reaches maturity, as evidenced by declining growth rates, or the landowner knows that the tree will die before the next round of cutting. The tree is not cut simply because it is big. This system, more than others, demands that the landowner regularly visit the forest, take notes, and really get to know the dynamics of tree growth. These regular visits will also increase his or her powers of observation that could catch developing situations before they become big and costly headaches. But within the unique region of the Central Ozarks, where competition from shade-tolerant red and sugar maple is not a significant problem, we have an excellent example of single tree management. Over the past 50 years, St. Louis businessman Leo Dry and his team of forest managers at Salem, Missouri-based Pioneer Forest have restored over 146,000 acres of abused Ozark woodlands. Their basic strategy is to conduct a harvest in a given area about every 20 years, or when a particular stand achieves a closed canopy. Visible signs of growth have slowed, and individual trees begin to show signs of crowding, dieback, or disease. Choosing trees to harvest is as simple as cutting the worst trees and leaving the best. Harvests remove about 12 to 15 trees per acre, or 40% of the standing volume. The result is that as many or more trees of all sizes and ages are left standing as were cut during the harvest. As we emphasized in the Crop Tree Release Improvement Cut, proper spacing of tree canopies is important in order to ensure healthy, vigorous growth of the remaining trees.